All right, so this is quiz number 2. And it's on sections 5.1 and 5.2. So it's all about our radicals and exponents. So for number 1, it says find the indicated real nth root of a. So the n is my index, and the a is the number that goes under the radical. So I'm looking for the 4th root of 16. So what are 2 factors of 16? 4 and 4, and 2 factors of 4? 2 and 2. Now the 4th root tells me how many of a kind that I need. How many? 4. So I have to circle 4 of a kind. So what comes to the outside? 2. So my answer would be 2. All right, let's look at C. So here I'm taking the 5th root of negative 32. When it's negative on the inside, you always have to ask yourself, can I do this? Can I take the 5th root of a negative? No. Yes, because it's an odd index. So odd, you can take a negative on the inside. If it was even, you can't. So let's say I had the 4th root of negative 8. Could I do this? No, this would be no real solution. So keep that in mind. If it was an even index, you can't. But odd, we can. A negative on the inside just means that our answer is going to be negative. But we got to figure out what value. So what are 2 factors of 32?
8 and negative 4.
8 and 4. And 2 factors of 8? 4 and 2. And 2 factors of 4? 2 and 2. Negative 2. Since it's a negative on the inside, our answer is negative. So when it's an odd index, if it's a negative on the inside, our answer is negative.
And plus or minus is only 1.
Plus or minus is when you're solving.
But even numbers?
Yeah, which we'll get to that part. All right, let's look at D. So I'm looking for the 6th root of 0. What is the 6th root of 0? 0. Be careful. Some people said this was 1 yesterday, but it's when you have any number to the power of 0. So let's say I had 6 to the power of 0. What would this be? 1. 0 as an exponent makes your answer 1. But if it's 0 on the inside, your answer is 0. What if I had the 6th root of 1? What would my answer be? 1. Perfect. Good with this section? All right. The next part we are solving. We're solving for x. So when solving for x, if it's an even index, you have to do plus or minus. Odd index, you don't. So even index needs your plus or minus in your answer. So let's look at A. What would I do first to solve for x here? Multiply by 3. We need to get that x to the 4th power all by itself first. So I'm going to multiply both sides by 3. So it cancels out with the 1/3. So if x to the 4th power is equal to 27 times 3, which is 81. Then what should I do? I take the 4th root of both sides, because the 4th root will cancel out with the 4th power. So whatever our exponent is, that's what type of index we need. So I have x is equal to, now I need to figure out the 4th root of 81. So what are 2 factors of 81? 9 and 9. 2 factors of 9? 3 and 3. I'm circling how many of a kind? 4 of a kind. So what would my answer be?
3.
Just 3? Plus or minus 3. Because it was an even index. Even exponent, even index. Even means that it is plus or minus. So you need that plus or minus in your answer when it's an even index. So before you even start this question, if you have an even exponent, you need the plus or minus in your answer. So make a little note before you even start. You need plus or minus. All right, let's look at B. What should we do first to solve B? Move the 10. So I'm going to subtract 10 on both sides. So x to the third power is equal to negative 8. What would I do next? Perfect. I take the cubed root of both sides because my exponent is 3. Is my answer here going to be plus or minus? No, because it's an odd index. So we don't have to worry about plus or minus here. But we need to figure out the cubed root of negative 8. What are 2 factors of negative 8? 4 and 2. 2 factors of 4? 2 and 2. I circle how many of a kind? 3. So what's going to come to the outside? Negative 2. Awesome. Because it's negative on the inside, my answer is going to be negative. All right, I want to do one more just for fun. So I'm going to call this C. So let's say I had x plus 2 to the third power of, or is equal to 27. What would I do to solve?
Distribute the 3.
I would take the cubed root of both sides. We don't distribute the 3, because if you did, it would be x plus 2 times x plus 2 times x plus 2. And you'd have to flip. It would be way too much work. So we cube root both sides, and that'll cancel out with the exponent there. So now I'm left with x plus 2 is equal to, let's find the cubed root of 27. What are 2 factors of 27? 9 and 3, and 2 factors of 9? 3 and 3. I'm circling how many of a kind? 3. So what would this be equal to? 3. Do I need a plus or minus here? No, because it's an odd index. What is the last step? Subtract 2. So what does x equal? 1. All right, let's look at the next part. So we need to evaluate these. What's my index here? 6. Whatever the denominator is, that is the index. So I'm looking for the 6th root of 64. Well, what are 2 factors of 64? 8 and 8. 2 factors of 8. 4 and 2. And 2 factors of 4. 2 and 2. I'm circling groups of how many? Groups of 6. And how many 2's do I have? 6. So what would my answer be? 2. Just regular. So you only put plus or minus when you're solving, when you have equal signs. So only for this question, when you have x in the question. All right, let's look at B. So what's my index here? 4. So I'm looking for the 4th root of 81 to the third power. So don't forget about the exponent. What are 2 factors of 81? 9 and 9. 2 factors of 9. 3 and 3. I'm circling groups of how many?
4.
Groups of 4. Do I have a group of 4? Yep, I got 4 of a kind with my 3's. So it means a 3 can come to the outside. But I can't forget about the exponent. What is 3 to the third power? 27. So here I have a negative exponent. What does the negative do? It puts it in the denominator. So this becomes 1 over 16 to the 3/4 power. Now what's my index? 4. So this is 1 over the 4th root of 16 to the third power. So what are 2 factors of 16?
4 and 4.
4 and 4. And 2 factors of 4?
2 and
2 and 2. Circling how many of a kind?
4.
So what comes to the outside?
2.
2. To what power?
3.
To the third power. Don't forget about the exponent at the end. And what's 2 to the third power? 8. So what's my final answer? 1 over 8. Don't forget, negative exponents turn it into a fraction. All right, number 4, we're looking at our properties of exponents, and we're simplifying. So when I have the same base and I'm dividing, what do I do to the exponents to combine? Subtract. Well, what's my exponent on top? 1. So I subtract 1 minus 1/4. Because I just subtract the exponents. Now I have fractions here. What do I need if I'm going to subtract fractions? Same denominator. So what can I change 1 to be? 4 over 4. Bless you. So now I just subtract the numerators and keep the denominators the same. So this is 6 to what power? The 3/4 power. That's my answer. We can just leave it like that. Not for these. All right, let's look at B. What could I do first here? I could distribute the -1. What else could I do first? Did anybody do anything different? If I'm multiplying and they have the same base, how can I combine them together? Add the exponents. So I can add the exponents. This would be 4 to the -2/3 power plus 1/3. So perfect. Here they already have common denominators. So when I add these two together, what do I get? The -1/3. What would I do next? Multiply. When you have a power raised to a power, we multiply. So what is -1/3 times -1? Just positive 1/3. So this would be 4 to the 1/3 power. If you distributed first, then you could have added them together. You'll end up with the same answer. All right, let's look at C. For C, what would we do first? I can distribute the -1/3 to the exponent on the 9 and the exponent on the 5. Well, what's the exponent on the 5? 1. So this is 9 to the power of 3 to the -1/3 power over 5 to the power of 1 to the power of -1/3. Now you don't have to write this down. You could just go ahead and multiply, but some people like to see the steps written out. So what do I do when I have a power raised to a power? Multiply. Now, if it helps, make your whole number a fraction. Make it 3 over 1. And how do I multiply fractions together? Multiply straight across. So here I would get -3 over 3, which would simplify to what? -1. So this would be 9 to the power of -1. When I multiply here, it's 1 times -1/3, which would just be -1/3. So 5 to the power of -1 over 3. Now I can't leave negative exponents in my answer, so what do I have to do? Flip it. If it's negative on the top, where does it go? To the bottom. If it's negative on the bottom, where does it go? To the top. So this would be 5 to the power of 1/3. The exponent becomes positive, and this would be 9 to the power of 1, but do I write the power of 1? No, so just 9. So this would be our answer. All right, let's look at D. So for D, my bases are not the same, but the radicals are. So how can I multiply these together? Multiply the insides and keep the radical part the same. So I'm doing the 4th root of 6 times 8. Now you can multiply 6 times 8, but we're going to want to simplify it. So let's just break it apart from here. What are 2 factors of 6? 3 and 2, and 2 factors of 8, 4 and 2, and 2 factors of 4, 2 and 2. How many of a kind do I need to circle? 4 of a kind. Do I have 4 of a kind? So what comes to the outside?
2.
A 2. And I still have something left on the inside. What would be left on the inside? 3. So I have 2 times the 4th root of 3. Whatever your radical is in the question, I have the 4th root here, the 4th root here. I need the same radical in my answer. So it has to have the same index in your answer too. So it needs to be the same radical. All right, let's look at E. So here, all my terms have the same index and the same radical. So what could I do? I can combine them all together. So I have the cubed root of 6 times 72 divided by 2. Put them all together. Now you can multiply 6 times 72 and then divide by 2. Or you could just divide like one of the numbers by 2 and then multiply. So this would be the cubed root of 6 times 36. And then break it down from here. What are 2 factors of 6? 3 and 2. And 2 factors of 36?
6 and 6.
6 and 6. 2 factors of 6?
3 and 2.
3 and 2. And 3 and 2. Well, I need how many of a kind here?
3.
3. Do I have 3 of a kind?
Yes.
I have 3 3s. So what's going to come to the outside?
3.
A 3. And what else do I have?
2.
I have 3 2s. So a 2 also comes to the outside. What do I do if I take out more than one number? Multiply. So what would my answer here be?
6.
6. You could have also noticed from the beginning that this would be 6. 3 6s. So you could have stopped there. Number 5. We have to write the expression in simplest form. So what do I need to do to simplify? I can't leave my radical in the denominator. So what can I do to get rid of it? Multiply the denominator by the conjugate. So what would my conjugate of 3 plus square root 2 be? 3 minus square root 2. And if we multiply that on the bottom, we have to multiply the same thing to the top. So you can't just do it to one of them. You have to multiply the same thing to the top and the bottom. So on the top, we can distribute the 6. So we get 18 minus 6 square root 2. And then on the bottom, what could I do to multiply these two together? I could FOIL. What else? It would be 3 squared minus, always minus, square root 2 squared. So it's the first number squared minus the second number squared. Always minus in the middle. So 3 squared is 9 minus, what is square root 2 squared? 2. And what's 9 minus 2? 7. So this would be our answer. All right, what is my conjugate for 4 minus square root 5? 4 plus square root 5. The sign changes. Sign in the middle changes. So 4 plus square root 5 gets multiplied on the top and the bottom. So let's multiply the top first. We distribute. So I get 28 plus what? 7 square root 5. Perfect. Be careful. You can't multiply inside the radical if 7's not inside a radical. So it just stays out front. On the bottom, what could I do? 4 squared. What goes in the middle? Minus square root 5 squared. So because these are conjugates, we can do the shortcut. 4 squared is 16 minus, what's the square root of 5 squared? 5. And 16 minus 5? 11. So that would be our answer. All right, next page. We're writing the expression in simplest form, so I got to break it down as much as I can. What are 2 factors of 128? 2 and 64. And 2 factors of 64? 8 and 8. And 2 factors of 8? 4 and 2. 2 factors of 4? 2 and 2. Especially with these big numbers, I would say be as neat as possible, be as careful as possible when writing out your work, because if you miss a 2, then your answer would be totally off. So just be as careful as possible when writing out your factors. It's not a race. It's only 10 questions on the quiz tomorrow, so take your time with it. I'm circling how many of a kind? 5. So I have 5 2s here. So what's going to come to the outside? A 2, because I had 1 circle of 2s. What would come next? Is it the square root? The 5th root. Whatever your index is, it has to be the same one in your answer. And then I have 2 2s left on the inside. So what do I do to them? Multiply. So 2 times the 5th root of 4. So if you have a 5th root in your question, It's got to be a fifth root in the answer too. All right, B. So B is one of those where we have to get the radical out from the denominator, so we are going to have to rationalize. We can split it up. I think splitting it up helps us rationalize. So I have the cubed root of 7 over the cubed root of 4. That way we're just dealing with the denominator here. We got to make sure that our denominator does not have a radical in it. So let's find our factors of 4. What are 2 factors of 4? 2 and 2. So I have 2 2's. How many 2's do I need to make a perfect group? 3, because my index is 3. So how many more 2's do I need? 1. So I'm going to multiply whatever my index is. It has to be the same. So the cubed root of how many 2's did I need? 1. So just the cubed root of 2. And then whatever we multiply on the bottom, we have to multiply the same thing on the top. So on the bottom, now I have a group of 3 2's. So what's going to come to the outside? 2. On the top, how would I multiply these together? Just multiply the inside. So it would be the cubed root of 14. And this would be our answer. You cannot divide that 2 into the 14 because the 14 is in the radical. It's protected by that house there. You can't divide the 2 into it. So this is our final answer. All right, let's look at C. So again, we have to rationalize. What are 2 factors of 8? 4 and 2, and 2 factors of 4? 2 and 2. If I don't have anything written out front as my index, what do I circle? Groups of how many?
2.
Groups of 2. If you want to write the 2 as your index, that's fine. Make sure that you know if there's no index written there, it's implied that it's a 2. It's the square root, 2. All right, so I have a group of 2 2's, but then I have a lonely 2 on the inside. So what would I need to multiply to make that a full group? The square root 2. So now I have another group of 2's. What else do I have to do? Multiply it to the top 2. So what do I get on the bottom?
2.
Why is it 4? Because I have 2 groups of 2. So I have a set of 2's here and a set of 2's here. So 2 times 2 would give us 4 on the bottom because we had 2 groups of them. And then on the top, what's square root of 3 times the square root of 2?
6.
Square root 6. And that would be our answer. So bonus example. Let's say I had the 5th root of 7 over the 5th root of 4. And I had to rationalize. Can't leave a radical in my denominator. So what are 2 factors of 4? 2 and 2. So I have 2 2's. How many do I need to make a perfect group? I need 5. So how many am I missing? 3. So I would have to multiply by the 5th root of 2 times 2 times 2. I need 3 more 2's. Because I needed a group of 5. So on the top, I can multiply by the 5th root of 2 times 2 times 2. But what's 2 times 2 times 2? 8. So these are technically the same thing. They just look a little bit different because I left it multiplied out here. So I can see that I have a group of 5. So I have my perfect group of 5 here. So what comes to the outside? A 2. And then on the top, I have the 5th root of 7 and times the 5th root of 8. How do I multiply those together? Multiply the inside. So it's 7 times 8. 56. Now, you can always check to see if it can be simplified or not. So I have the 5th root of 56. What are 2 factors of 56? 7 and 8. Perfect, what we just multiplied. What are 2 factors of 8?
4 and 2.
4 and 2. And 2 factors of 4?
2 and 2.
Do I have a group of 5?
No.
No. So it can't be simplified, so this is our answer. All right, 7. So 7 I'm subtracting. When subtracting, you got to make sure that you have the same variable part. Are these variable parts the same? Yes. So we just subtract the coefficient. So what's 3 minus 14? Negative 11. And the variable part stays the same. So the cubed root of x, y. So negative 11 times the cubed root of x, y. Same thing with number 8. Are my variable parts the same? Yep. So we just add the coefficients together. What's 12 plus 4? So 16x to the 3/2 power. All right, let's look at 9a. So we're simplifying. I got to break down everything, but let's do it one letter at a time. So let's start with the numbers. What are 2 factors of 64? 8 and 8. And 2 factors of 8? 4 and 2. So 2 factors of 4? How many of a kind do I need a circle? 3 of a kind. So, because how many 2's are going to come to the outside? 2. And what do I do if I take out more than one number? Multiply them. So I have 4 on the outside. All right, let's do the R now. How many R's do I have?
4.
And I need to circle groups of how many?
3.
Groups of 3. So how many R's are going to come to the outside? 1, because I have one group of R's. Do any have to stay on the inside? 1 R stays on the inside because that 1 R did not get circled. So I have the cubed root of R left on the inside. Now notice how I put the cubed root because I have the cubed root in my question, so I need the cubed root in my answer too. So now let's do the S's. How many S's do I have? 8. If it helps, write them all out. I'm circling groups of how many? 3. So I have 3, 3, and 2 left over. How many are going to come to the outside? 2, because I have 2 groups. 2 groups got circled. So how would I write that? S squared, because I have 2 that comes out. So S times S. How many are left on the inside? 2. So how would I write that? S squared. Perfect. So this would be our answer. All right, let's look at B. So here, before we simplify, I'm going to split it up because we're just doing one letter at a time. So let's do the K's and then we'll do the N's. So I have the 5th root of K to the 5th power over the 5th root of N to the 7th power. So we can do the top first. How many K's do I have up top? 5. And I'm circling groups of how many? Groups of 5. So how many K's come to the outside? 1. Do I have any that are left on the inside? Nope. Perfect. Let's do the N's. How many N's do I have? 7. How many do I circle? 5. So how many N's come to the outside? 1. And then I have the 5th root of how many N's on the inside? 2. So N squared. Yes. Now what is wrong with this? I can't leave a radical in the bottom. So I have to rationalize. So looking at my radical here, how many N's do I have? 2. But how many do I need to make a perfect group? I need 3 more because I need 5 total. So I'm going to multiply this times N cubed. So then on top, I have to multiply it by the same thing, the 5th root of N cubed. So now on the bottom, I have a perfect group of 5. So an N comes out from this group. But now how many N's do I have on the bottom? 2. So it would be an N squared on the bottom. And then on the top, can I multiply these together? No, so I'm just going to leave it as K times the 5th root of N to the cubed, to the 3rd power. So you have to rationalize. And be super careful when simplifying. If something was on the bottom, make sure you leave it on the bottom. So here, the N's had to stay on the bottom when we simplified. Then we rationalize. A lot of people, when you were doing this, even though an N came out, they did K times N outside. But that N just had to stay on the bottom until we rationalized. So let's say I had the cubed root of a to the 6th power over the cubed root of b to the 7th power. Okay, so let's simplify. We can start with the top. How many a's do I have? 6. I'm circling how many of a kind? 3. So how many a's are going to come to the outside? 2, because I have 2 circles of a's. So how would I write that? A squared. Perfect. So now let's look at the bottom. How many b's do I have? 7. How many of a kind do I circle? 3. So I have 3 b's here, 3 here, and 1 left over. So how many b's come to the outside? 2. So b squared on the outside, and then I have the cubed root of b left on the inside. Could I leave my answer like this? No, because you can't leave a square root in the denominator, so we have to rationalize. So we're rationalizing just like what we did before, but we just have letters now, which is fine. Now we need to get rid of that cubed, the b cubed from the denominator, the radical there, the cubed root of b. So how many b's do I have in that cubed root? 1. How many do I need to make a perfect group? 3. So how many more do I need? 2 more. So I'm going to multiply this by the cubed root of b squared. And then the cubed root of b squared on the top. So now on the bottom, I have a group of 3 b's. So how many b's are going to come out now to join the b squared that's already outside? 1 more. So b comes out. Well, what is b squared times b? B cubed. Now on the top, can I multiply a squared and the cubed root of b squared together? No, so I just leave it as a squared times the cubed root of b squared. And that would be our rationalized answer.